Hey there, math fans. When it snows, if you make a big snowball and bring it in your house, how long do you think it takes till it completely melts? Let's take a look. Here's a time lapse. The time is in hours. That's 1 hour. That's 2 hours. And you can see the snowball melting. I had my special assistant helping me during this project. He's very cheap to pay. But you can see it melts like this. I'd always wanted to do that experiment because it's a problem that comes up in our differential equations course. It's a fairly basic assumption. It says assume snow melts at a rate proportional to its surface area. It turns out it's a pretty accurate model. I used this exact data to model this, and that's the sphere you're seeing above. And it's a nice little exploration of what do we mean by proportional to, how do we turn this into a differential equation. So I made 3 videos on this about 6 months ago. Now at the time of doing that, these were some of my first videos, and so I thought I would circle back to them and add them to this nature series. I will link to them in the description. Also, since then, I wrote up a short little project that would work well in a Calculus 2 course. But what I like about it is it's one of these things that illustrates some things from Calculus 1, related rates, things like that. Illustrates some things from Calculus 2, where we integrate and solve, and also has some interesting theory, because this is a non-linear differential equation for the volume. It turns out the radius changes linearly, but the volume is a non-linear differential equation, so you actually don't get uniqueness given various initial conditions. My quick explanation of that is if you have a puddle on the ground, you don't know when the snowball started melting. And so there's other solutions that could have led to that same puddle. But anyways, I since then have been coming across articles on recent research on melting ice. So I'll follow up with another video on that, but I just wanted to circle back and say, hey, if this interests you at all, I think this is a nice little snapshot of things that use Calculus 1, 2, and 3 and differential equations. And so it might be a nice little project for you to check out. Or you might want to check out my 3 videos, because I think those would give you a nice picture of some of the things you're going to do in these courses. All right. Thanks for listening.